Imagine the most massive objects in the universe. We're talking about supermassive black holes. These behemoths live in the centers of galaxies. They are millions, even billions of times heavier than our sun. Black holes are regions of extreme gravity. Nothing, not even light, can escape their pull. These cosmic giants are invisible to our eyes. They don't emit light, but we can detect their influence. Black holes gobble up surrounding gas and stars. This process releases a tremendous amount of energy. We see this as powerful jets and radiation. These black holes are not just cosmic vacuum cleaners, they play a fundamental role in the evolution of galaxies. Their gravity shapes the galaxies around them. Understanding these giants is key to understanding our universe. Galaxies, like our Milky Way, are constantly moving. Sometimes galaxies collide. This sets the stage for a cosmic dance of epic proportions. When galaxies merge, their central black holes spiral toward each other. This dance can last for millions, even billions of years. As the black holes approach, their gravitational pull distorts the fabric of spacetime. This distortion creates ripples known as gravitational waves. The closer the black holes get, the stronger the waves become. The dance culminates in a spectacular collision. The energy released during this merger is unimaginable. It's more energy than all the stars in the universe combined. This energy is released in the form of gravitational waves. These waves travel outward at the speed of light. Gravitational waves are ripples in the fabric of spacetime. Imagine throwing a stone into a pond. The stone creates ripples that spread outward. Gravitational waves are similar. They are created by massive objects moving through spacetime. Albert Einstein predicted gravitational waves over a century ago, but they were only directly detected in 2015. The Laser Interferometer Gravitational Wave Observatory, or LIGO, made this groundbreaking discovery. LIGO detected waves from two black holes colliding over 1 billion light-years away. This detection was a major scientific breakthrough. It confirmed Einstein's theory of general relativity. It also opened a new window into the universe. Gravitational waves allow us to study objects and events that are invisible to telescopes. The detection of gravitational waves from merging black holes is just the beginning. Scientists are now using these waves to study black holes in unprecedented detail. Each merger event provides valuable information. We learn about the masses and spins of the black holes involved. These observations are helping us to test our understanding of gravity. They are also providing clues about the evolution of black holes. Some scientists believe that studying these collisions could lead to a unified field theory. A unified field theory would combine all the fundamental forces of nature into one framework. This is one of the biggest challenges in modern physics. Gravitational waves could hold the key to unlocking this mystery. The universe is speaking to us through these cosmic echoes, we just need to listen.